Welcome everyone to another easy programming tutorial with C++. This is my first tutorial in a few months. The only reason I haven't been able to submit more tutorials is because I've had a lot of problems with technology, and I've gotten really busy over the past 3 months to do much about any of the issues that I've had. But now I'm back and I want to continue where I left off last time. Last time I left off finishing C++ stacks, and I said I'll do C++ Q soon, and this is a tutorial that quite a few people have emailed me about. I thought I'd just do that. I'm going to take the same approach to teaching C++ Qs as I have with C++ stacks, and that's turn it into several parts. The first part, this is it. I won't be teaching any codings. I won't be coding. You can copy, but I will show you the backbone of queues, what they are, explain to you exactly what it is. I do have the tutorial ready for the next program or for the next video where I will show you the actual coding, and this is it. It's a pretty big program, but it's fairly simple. If you understood stacks, this is actually pretty simple. It's very similar. But stacks is a last in first out kind of program, and queues are first in first out. To understand queues, you can look at it as like a line in a supermarket or an amusement park. The first thing that goes in is the first thing that comes out. And I've set up a little box here to show you an array of exactly what it's like. It's really simple. When the front and the back numbers in stack, you have stack.top, and queues you have front and back. Some books will say rear, that works too, but in this case I'm going to use back. And when they are the same, front and back is the same, that means the queue is empty. Now if you want to enter something into a queue, let's say David, I'm going to put it into 0. The value of back will change, it'll go to 1, it'll change to 0, and the front will be 4. The queue is no longer empty. You put in Michael, and now the back will change to 1. If you put in Terry, the back will change to 2. The function we will be using is called enqueue, but when we include queue into the header, we will use push. It's the same as stack.push. This will be queue.push. When you're popping values out of the queue, you have to do it first out. The first thing that came out is the first thing that comes out. The first thing that went in is the first thing that comes out. It's the opposite of stacks. It's the last thing that goes in is the first thing that comes out. This is like a line. So when you take out David, we'll be using the function called dequeue. But when we include queue, it'll be pop. And when you do that, the value of front changes. See, the front is no longer 0, it's 1. When you take out Michael, excuse me, the front will change to 2, because that's the first person right now. If there's anything behind, the back will be changed. And then when you take out Terry, the front will change to 2. And well, again, when they're the same, the queue is empty or the line is empty. This is how stacks work. Queues work. It's really simple. I thought maybe a visual would help. See what it's like. And once it fills out again, queues just rotate all the way to the front. It can just keep going. The value of front can change. Any of these numbers can be the back. Any of these numbers can be the front. Unlike stacks, where the first number 0 is always the front and the last number is always the back. The functions we will be looking at are these. We have 5 here. There's actually 6, but I won't actually go into the other one. The first one is create queue. Create queue is also the initialize queue. It initializes the queue to create an empty state. What this will do is basically set the value of front and back to be the same. And when I'm coding, I'll explain that to you exactly where I'll set it. And the next one is enqueue. This is when you're adding queue or pushing. This adds a new element to the rear of the queue, to the back. And the input of this operation consists of the queue and the new element. As you can see, we're sending back queue and the new element. And before you can do this, the queue must not be full, and that's where this function comes into the boolean. It checks to see whether the queue is full, and if the queue is full, it returns the value of true, otherwise it'll return false. Void dequeue is the same as pop. When we do include queue, we'll use pop. I'm sorry, this is the same as delete queue. It removes the front element of the queue, as the first in, first out. The input of this operation consists of the queue and the element that's coming out of it. And prior to this operation, the queue has to be existent and must not be empty. And that's where the next function comes in, and that's empty queue. Empty queue determines whether the queue is empty. If the queue is empty, then it returns a value of true, otherwise it'll return false. We'll be doing this in an if function, if statement. And these are the basic functions that I'll be showing in the coding in the next video. And there's another one called destroy queue. It's a destructor, and this is the constructor. It creates the queue, and the destructor basically destroys it, and the function of it is the same, but I won't be doing it in this case. Maybe later on when we include queue, I might do that just to delete the queue, clear up the memory space. And when we do include queue, we'll also have a few other functions, built-in functions, including size. Well, actually, that's about it. It'll show you the queue size. In the program that you'll be seeing, this one has a max queue. I don't want the queue to go forever in this program, but when we include queue in the header here, there will not be a max, so we won't be using full queue on the Boolean function. Anyway, this tutorial video is to serve as a basic understanding to help you understand what queues are. In the next program, I'll actually go into the video of coding, and we'll go through all of this. It won't be too long. Again, like I said, if you understood stacks, it's similar. You have create stack, you have full stack, empty stack. The enqueue and dequeues are the only ones that are different. But again, when we do include queue, we'll put in push and pop, and hopefully that'll make a lot more sense. I'll go into what each of these functions do later on in the next video. And well, thanks for watching, and remember to subscribe, and be sure to check back in a few days when I have the second part of the video up.